So far, we've seen that whenever you encounter an indeterminate form of 0 over 0, whenever you encounter 0 over 0, then you can apply L'Hopital's rule. You can just differentiate the top, you can just differentiate the bottom, and then try and find the limit of this. So now we're going to consider the case of infinity over infinity. So if you're trying to find the limit as x approaches a, and this happens to tend towards infinity, and this also happens to tend towards infinity, then as it turns out, you can still apply L'Hopital's rule because of this. Let's say you've encountered a situation where this thing here is heading towards infinity, and this thing here is also heading towards infinity. Well, you can write this whole fraction here as this. So here you've got one fraction. Basically, we are just rewriting this fraction as this whole thing here. It's exactly the same thing but written in a different way. So we can rewrite this whole thing here as this, because if you look at this here, we've got one fraction divided by another fraction. So we've got one fraction divided by another fraction, 1 over f of x. Well, that's the same as us. So we would keep this the same, so g of x, and then we would times the reciprocal of this. So that would be this over 1, and then top times top, which would be f of x, and then bottom times bottom, that would be g of x. So this is exactly the same as this. The point here is that this can be rewritten as this. They're both the same but written in a different way. So remember, this thing here is heading towards infinity. This thing here is heading towards infinity. So if g of x here is heading towards infinity, then if you have 1 over infinity, then you can say that this is heading towards 0. And then remember, this thing here is saying this thing is heading towards infinity. This thing is also heading towards infinity. Or f of x here is heading towards infinity. Well, if you look at this fraction here, this is also heading towards infinity. So you've got 1 over infinity. So this is really heading towards 0. So in a way, even though you've got infinity over infinity, it is a case of 0 over 0. It's just it is the case of 0 over 0. So you can apply L'Hopital's rule. So even though this is heading towards infinity, this is heading towards infinity. But if you rewrite it as this thing here, you've got a case of heading towards 0, heading towards 0. So you can apply L'Hopital's rule. So hang on. So if you have if this thing is heading towards infinity, this thing is heading towards infinity, then as it turns out, L'Hopital's rule still works. You can just differentiate the top, you can just differentiate the bottom. So this is for the case of infinity over infinity. As it turns out, infinity over infinity, it happens to be the same as 0 over 0. So you can apply L'Hopital's rule here. Okay, and also bear in mind that this thing also works as x tends to a from one direction, from the right hand side. Let's say this is a here. As it turns out, this still works if you're heading towards a from the right hand side, and it will also work if you head towards a from the left hand side, and it will also work if x is heading towards positive infinity, and it will also work if x heads towards negative infinity. I will give you some examples in the next video. Okay.